Number 6. A particle P moves along the x-axis for t greater than 0, and its position is given by the position function x of p of t is equal to 6 minus 4 e to the negative t. So this is moving along the horizontal, and this is a position function. Okay, so this is, I'm just going to note this is the position. Particle Q moves along the y-axis such that for time t equals 0, the velocity is given by vq of t is equal to 1 over t squared. And this is important that this is a velocity function. Okay, so we want to find the velocity of p, so we're going to differentiate the xpt. So we know that xp prime of t is equal to vpt. So in differentiating this, we get derivative of 6 is 0. We get negative 4 e to the negative t. Because that's a negative, we need to multiply by negative 1 using the chain rule. So my v function is going to be 4 e to the negative t. Okay, so that's the first part. That's the vp of t function. Part B says AQ, the acceleration of particle Q, so that's our vertical component. Q is vertical and P is our horizontal. The A gives us acceleration. Find all times for t greater than 0 when the speed of the particle Q is decreasing, and justify your answer. So the key to this problem is, first of all, we need to understand that we're talking about speed. Okay? And when the acceleration, A of t, is opposite of v of t, the speed will be decreasing. So anytime we have the acceleration working against the velocity, we have a decreasing speed. So the scenarios could be a positive velocity with a negative acceleration, or we can be going to the left, the velocity is negative, and the acceleration could be in the positive or towards the right. So they're working against each other. So first thing I'm going to do is I'm going to first of all find VQ and find the zeros of that. So starting with my V function, okay, VQ of t is equal to 1 over t squared. Okay, that we need to figure out when this is equal to 0. Okay, and there's no solution to this. Okay, so then we need to check to see which direction this is going. So this is not going to change direction, but we know that the direction is going to be, I'm just going to plug in a value here. I think the domain was greater than 0. So I'm going to just plug in VQ of 1, and we get positive. So we know that for for the whole time, we know it's moving to the right. Okay, we know the velocity is moving to the right. So I'm just going to put that in my chart here. I know for all real numbers, for t greater than 0, it's moving to the right. So then I need to work out the acceleration. So AQ of t, when I differentiate this, I'm going to get negative 2 t to the negative 3, so t cubed in the denominator. So this is then our acceleration function. We need to know where this is equal to 0. Okay, it's going to be equal to 0 when this is not equal to 0, so it doesn't change. It's not going to change direction. Okay, so sorry, it won't change direction when t is positive. So there's no solution here. So then we can just show that by testing a point, and we have negative acceleration for the whole time. Okay, when t is equal to 1, it's equal to negative. So we know that we have negative acceleration. So we know that accelerating the whole time it is accelerating to the left. So for t equals t greater than 0, we know that the speed of the particle q is always decreasing. Okay, so this is an always decreasing function so it is speed is decreasing for t is greater than 0.